Yo, what's up, everyone? So we're on review set 5, and there's going to be 7 review sets, but the last one I'm just going to give you answer keys to, inference, because we did a ton of that in online week 1 and 2. So if you want to review that, you can, or you can use the answer keys as a reference. But with that being said, this question we're going to do, number 3 in your packet, is really awesome because it talks about how the sampling distribution relates to inference. So this is going to be essentially a significance test, but it's through the odds of the sampling distribution. So we did one sampling distribution question before. We know that it's just all the possible samples we could get from a population, because sometimes your sample is going to be way bigger or way smaller than the actual population. So, read the question, and it says, in a report to the Department of Transportation of a Western state, a large trucking company said that the distribution of weights is normal and as a mean, yada, yada, yada. Okay, so we're just talking about the weights of trucks. All the rest of it's annoying. And we know that these trucks are normally distributed with a mean of 19,000 and a standard deviation of 2,000. They want to test this with a sample of 40. So this is really common. And this is how a lot of the inference questions are going to be. They're going to give you the mean and the standard deviation and the sample. But usually those questions are just like straight solve it. But what it asks us here is a little different. And this is something I think would be really likely to be on the exam. Reason being, there's going to have to be a lot of sections. So for them to ask you to describe the sampling distribution, I think is going to be like something that could definitely be on it. So it says that assume that 19,000 is true. We want to describe the distribution of the sample. We want to describe the distribution of the sample mean weight for random samples of 40 trucks. And all of that is to say, we want to talk about what would the distribution of all the possible samples be. And this is what the sampling distribution is. We know that there's a distribution of trucks. Some of them weigh more, some of them weigh less. But we want to know, if we take a bunch of trucks, what would that sample look like? What would the mean weight in that sample be? And there's a few facts we know that makes this really simple. And this is the most beautiful part of statistics, and without this, probably stats wouldn't exist, because the logic and all of that is just so wonderful. So first thing is that if we take a sample of 40 trucks, we can draw it and it's normally distributed, okay, where most of the samples are really close to the actual mean. So if the average truck weighs 19,000 pounds, then the average set of 40 trucks is also going to average 19,000 pounds, which sounds really simple, but make sure you understand exactly what I'm saying. So not only is the average going to be the same, the mean of this sampling distribution is the same as the mean of the distribution, but it's normally distributed, which is really powerful because we can do a bunch of math with the normal distribution. Okay? So when it says, it's actually saying describe, so let's talk about this. The first thing is, and I'll say it and then speed through writing it, but the distribution is normally distributed. The sampling distribution is normally distributed with a mean of 40. So that's step 1. And then the other thing we could want to kind of talk about is the spread of the data. Always think center, shape, and spread. The shape is normal, the center is 19,000. But if we want to find the standard deviation of this distribution, that's when we use the new formulas, okay? And that means that we take the standard deviation given to us and divide by the square root of sample size. Logic being, the larger the sample size, the closer all the samples are to the average, okay? I'm not even strapped to my calculator right now. Okay, so let's solve this, and then we can put this in our written answer when it says describe. So square root of 40, first of all, 232 divided by that. So the standard deviation of this distribution is 367.457. And we don't even need to draw the whole thing. It's not saying draw the distribution. That is possible. It could say draw the distribution, and that would actually be something we would crush. But it's saying describe, so first center and shape, and now spread. the standard deviation cool. So that's A. And then B says they actually do this. They take a sample of 40 and find the mean to be 19,168, so super close in context. What is the probability that a random sample would have this mean or more if the claim is true? So what I really like about this is that it's not asking you to do a significance test, but this is what a significance test is, okay? You always take a sample. So this is the sample mean. And when you have that sample, you compare it to the claim, in this case, this number, and it's part of the sampling distribution, okay? So what I mean by that is we already said that if we take a sample of 40, it's going to be normally distributed with this is the center, and this is the standard deviation. So if we're trying to figure out how likely is it that it's this number, commas don't really work that well. If we're trying to figure out this number or greater, that's what it said. All we have to do is do a z-score question, okay? Mean, data point. The data point's always your sample, standard deviation. Does that make sense to everyone? And this, I think, is one of the most important questions I'm doing in the whole review. I'm trying to think, I might put like a star next to the ones that are the most important per unit, because there is definitely like one or two that are really important. So I think I'll probably put like a star for this one to watch. But if we're trying to find how likely is it that it's this outcome or greater, that's what a significance test tells you. Whatever that percentage is called the p-value. And if this is really small, it makes it hard to believe that this is true. Okay, and that's why we reject significance tests, because this value, getting our sample or even far away from the sample, if that's really unlikely, this doesn't seem like it's true. So while this question is not asking us to solve for a significance test, it's asking us to solve for a significance test in words. So I love it. One thing that's interesting is like you would actually use a T if you're doing a significance test, but here we don't need to do that, okay? Because we're not running an entire test. It's not asking us to fail or reject anything. Honestly, I don't love that explanation. I just thought about that right now. And if I delete it, people probably wouldn't notice, but if I don't delete it, I'm being honest. But yeah, we're gonna use a z-score here because, actually, I'm just gonna check. Oh, okay, this is awesome. I'm really happy. The reason that we just use a z is that we know the actual standard deviation. And this is a little complicated. I don't want to get into this too much because most of you would have used z to begin with for this question. But the reason that we have to use the t distribution is that in most questions, we don't know the true standard deviation. Okay, this question gave us both of them, and that was pretty useful to us. But usually this isn't given because we just find this, like, we're usually making a claim, but we're not ever making a claim about a standard deviation. Okay, and if we have to estimate the standard deviation, then it becomes less accurate, and t is used for less accurate significance tests. Okay, so you would use the z here, and I'm going to use the calculator method, normal distribution, NCD, lower, upper. So 9, and I love these calculators. Okay, just so everyone knows, we're trying to find the percent of data above this. So this is lower, and then infinity is upper. And the standard deviation is of the sampling distribution, and the mean is as well. So we're going to get this to be 0.33956. And I'll tell you one good thing about doing someone else's questions is that they get better p-values pretty much every time. Because my questions, a lot of times, I forget to check them, and I give you numbers that don't work perfectly. So this is a really big value, and that value represents how this section, and this is a really big percent, so that indicates that their claim is pretty accurate. You would fail to reject this if it was a significance test. Now, the second one, this third thing is, I think, the least important of the three, but it's asking her basically to talk about one of the conditions. So it says a different crew was assigned to check the trucks to weigh them, and they believe that it's too complicated to do a random sample, so they just do the first 40 fully loaded trucks as they leave the terminal and find a new weight that is smaller. So this would be the new sample. Why is the lack of random selection in using the first 40 trucks a potential problem? Now, this is the stuff in stats which is mostly just common sense, but I, like, in a good way. You just have to think, why would the first 40 trucks out of the terminal not be accurate? And you could just say that obviously it's not like a random sample, like, And like, you could obviously say that this 40 is not selected from the entire day, but what's better in these questions is to give a logical explanation for why in this particular question the first 40 trucks is not going to be an accurate set. Okay, you got a smaller value here, and the first thing I was thinking was maybe the first few trucks would be bigger because those people are more ambitious because they're waking up earlier. That's the kind of thing I'm telling you to do for these kind of questions. But let's just think for a second. And then one explanation could be that the earliest truck drivers in a day are more on top of their work, so they have to load less. Something like that. I actually kind of struggled to think of a good reason why the first trucks, like, I'm just trying to think about trucks. It doesn't give us too much information about it, even though they give us all these words. It's a Department of Transportation of a Western state. A large trucking firm. So these truckers... Alright, I did kind of think of an explanation. So on the AP, if you have time, think outside the box. But the first truck drivers in the day might have to travel farther. And if they're traveling farther, it's probably more likely that they're carrying less weight because gas is expensive per pound, you know? So maybe those farther out shipments are going to be slightly smaller and more niche. So think about, like, San Francisco to Seattle as a truck, you might have like a lot of stuff, but if you had to take a truck all the way to the East Coast for some product, you might not want to have it weigh that much. So they're probably going to be more conscious of weight. So that's an explanation. I'm going to write that down here. But good work again today. Woo!